Right now, you're sitting, standing, or lying down, and you feel heavy. You think gravity is pulling you down. That's what we've all been taught since school. But what if I told you gravity isn't a force at all? What you're about to hear completely changed how scientists understand reality. And once you get it, you'll never see the world the same way again. Hey everyone, welcome to Nova Byte Learning Today. We're diving into one of the most mind-bending ideas in physics, Einstein's theory of gravity. Isaac Newton gave us the first big answer 300 years ago. His idea worked so well that we still use it to send rockets into space. But there was one problem. It couldn't explain everything. Then Albert Einstein came along and completely flipped the script. Let's break it down step by step in the simplest way possible. For Newton, gravity was a force. Big objects like Earth pull smaller objects toward them. The more mass something has, the stronger the pull. This explained why apples fall from trees and why planets orbit the sun. His equation was incredibly accurate. For 200 years. But then scientists noticed something strange with Mercury's orbit. It wasn't following Newton's rules perfectly. Something was off. Einstein had a thought experiment that changed everything. Imagine you're in a sealed box in space with no windows. If the box is accelerating upward, you feel pushed to the floor, just like gravity. Einstein realized there's no difference between gravity and acceleration. This is called the equivalence principle. It was the happiest thought of his life. So if gravity feels exactly like acceleration, maybe gravity isn't a force pulling you. Maybe it's something else. Einstein said, mass and energy bend space-time. Think of space-time like a big trampoline. If you put a heavy bowling ball in the middle, it creates a curve. Now, if you roll a small marble nearby, it follows the curve and spirals toward the bowling ball. It looks like the bowling ball is pulling the marble. But really, the marble is just following the straightest path on a curved surface. That's what planets do around the sun. The sun bends space-time, and Earth is following that curve. You're not being pulled down by Earth right now. The ground is pushing you up while you're trying to follow a straight path through curved space-time. When you're in freefall, like skydiving or orbiting Earth, you're actually feeling no force at all. You're in the most natural motion possible. Time runs slower near heavy objects. Your head ages slightly faster than your feet right now. Black holes are places where space-time is curved so extremely that even light can't escape. And the craziest part? You are being accelerated upward by the ground at 9.8 meters per second squared, right this moment. So, why should you care? Understanding this changes how you see the universe. You're not a passive object being pulled by invisible force. You're moving through a flexible fabric of space and time that massive objects bend. It also helps explain how GPS works, how black holes behave, and even future space travel. Newton gave us the what. Einstein gave us the why. And scientists are still trying to combine this with quantum physics. The universe is way stranger and more beautiful than we thought. If you enjoyed this video, hit the like button, subscribe, and turn on notifications. In the comments, tell me, did this change how you think about gravity? Next video, we'll talk about black holes and what happens if you fall into one. See you there.